Given a 2D matrix, each cell could either be empty or it could contain a knight. You can swap any two knights which are directly reachable by each other, and you can do this by any number of times. Tell the total number of different arrangements of this 2D matrix that you can.
Okay, so I guess we should get started with the question, right? So I'll
Yeah.
keep it Google style, right? In Google interviews, it's strictly like 45 minutes, right? So
Okay.
what I'll do is I'll write down the start time. The start time is 11:06. Okay,
Okay.
let's make it 11:07 just to be fair. So
Okay.
yeah, the first question is that you are given a 2D matrix, okay,
Okay.
and there um, each cell could be either empty or it could contain a knight.
Okay.
You know what a knight is?
Yeah, in the chessboard.
Yeah,
That
have
one?
you ever played chess wherein you know how knight moves?
Yeah, yeah, I have.
Right? Like 1, 2,
Yeah,
or 2, 1, something like that. Okay.
yeah.
So from one cell, can you tell me what all different places a knight can go to? How many different places?
So it actually forms an L shape. So it can go two steps top and one on the left, or two steps top, one on the right.
How many different places from one cell?
Two, three, four, four. If it's not
Like
out of.
two above, two down, two right, two left, right? Like think about it like that.
Um, so if it's at the center, two on top and one on the left, two on top, one on the right. So that's two. Uh,
See, let's say you're standing on a cell, right? Like you go
okay.
two up, one right, one left.
Yeah, that's two.
Two down, one right, one left.
Yeah, that's
Two
four.
right, one down, one left. One
Okay,
down, one up.
six. Yeah,
Two left,
eight.
one down, one up. Yeah. So we have
Yeah,
like total eight possible.
yeah,
Okay.
yeah.
So now it's just that like let's say you can swap any two knights which are directly reachable by each other.
Okay,
Okay, and you can do this any number of times.
okay,
Okay, even on the modified cell. I'll tell you what it is. Okay,
okay,
the final thing is that you want to tell the total number of different arrangements of this 2D matrix that you can have.
okay,
I'll tell you what it means, right? Let's say let's imagine that you have this chessboard, right? You have dot 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 means empty, and
okay,
you have a knight, and then there is this dot. Let's say we have a
okay,
dot, let empty, then we have knight, then we have dot, then we have dot, then we have dot. Okay,
okay,
uh, yeah, and let's say after that you might have more things. For example, let's say dot, then dot, then dot, then maybe let's say we have knight here, then dot. Okay, let's say you have this chessboard, right? Uh,
okay.
there could be
Yeah,
any number of knights. Now, the chessboard would be given, the 2D matrix would be given to you like this, wherein every character would either be a dot or a K. K would indicate a knight, and a dot means empty cell. So
okay,
now, the thing is that this is the initial configuration of the chessboard. Although every knight is written as K, but you have to assume that they are different.
okay, okay,
Like for example, this is knight 1, or second one is knight 2, and third one is knight 3, right?
okay. Yeah,
Now, can you see that knight 1 and knight 2 are directly reachable in one step?
yes,
Okay, so just for distinction, I'm going to put K1, K2, and K3, but understand that that would not be given to an input.
okay, okay.
So a different arrangement as per the question could be that I can swap K1 and K2, knight 1 and knight 2.
Yes,
Yes?
yes,
Okay. And in this modified chessboard itself, I can make more changes, or in this original chessboard, I can make changes. Okay.
yes, yeah.
So let's say if I make changes in original chessboard, can I swap knight 2 and knight 3 as well? Because they are directly reachable in one
Uh,
step.
yes, yeah.
Also in the modified chessboard, this one, I could have swapped knight 1 and knight 3 because they are also directly reachable now.
Knight one and knight three. Yes, yes.
Can you see actually knight 1 started at the top and knight 3 was at the bottom,
Mm-hmm.
and in the original chessboard, and I was still able to bring knight 1 at knight 3's position. Can you see that?
Yeah, yeah,
Yeah, although they
yes,
are not directly reachable, okay, but
yeah,
through a sequence of swaps they can come, okay.
yeah,
So there could be different possible combinations of this, right? Like there could be different total, some different number of arrangements. The question here is this only, that can you tell me how many different arrangements of chessboard you will have?
Okay.
The only
Okay.
input given to you is a 2D matrix of characters, wherein every character would either be a dot or a K.
Okay. Okay. Um, I can, the route that I could think of is I can start with 1K,
Mm-hmm.
and then from then on, I can check on what all knights I can reach from that position,
Mm-hmm.
and I can do a DFS call over there. So
Mm-hmm.
it'll be like a recursion.
Mm-hmm.
So how would I know that I have already like I already have the same configuration as maybe let's say I have an map where I'm storing all the 2D matrices. So if I have
Sorry,
already,
sorry, I
uh,
just sorry to interrupt.
yeah,
So, are you going to like actually swap things and then and
uh,
then store the configuration in a set or map, or and then find out what is the size of it?
um,
That's
uh,
gonna be a nightmare.
yeah, actually.
Uh,
So maybe I can just go about with the indices because they are different.
okay.
So let's say K1 is at position 0, 1, 0, 1, 2, 3. Yeah. So 0, 3.
Mm-hmm.
So from 0, 3, I'll be having at max 8 positions that I can swap with.
Okay.
So I'll be checking for a position such that it is not out of boundary and it reaches another K.
Okay.
If it reaches another K, I can swap them.
Mm-hmm.
So that'll be one swap.
So my question is, are you going to swap them?
No, I wouldn't swap them. I
Okay.
can maybe like store the indices of K1, so
Okay.
that'll be 0, 3, and then I can do another call for the swapped one. So that is for K2.
Mm-hmm.
So from K2's position, now where can I reach? So I'll be from K1, since I'll be swapping it to K2, and
Okay.
I'll be doing another DFS call.
Mm-hmm.
So now K1 is at the position of K2.
Mm-hmm.
So from K2, I can check for all the calls,
Mm-hmm.
even though it can go to again a 0, 3's position, since I'll be storing the indices value in, let's say, a set.
Mm-hmm.
So will not be entering into that.
Okay.
So again, I can go into K3. I can go into that position also, right? So I'll be going into K3, and I'll be storing 1 comma 2's position because that's where K1 would be right now. And
Okay.
after going into K3, I can again check for the 8 directions. Since either they'll be going into an empty cell or out of boundary, or
Mm-hmm.
even if it gets into a kth position,
Mm-hmm.
but we've already visited that,
Correct.
which is in the set. So we'll not be visiting that anymore. And if we come out of it, we can just return a 0 or something.
Mm-hmm.
So for K1, we found this. We found these configurations, these many number. So it can, because of that, it'll again go back to the recursion call of K2, and then we can just find for all the adjacent, all the keys.
So what you did was actually you found out that how many places K1 can go to.
Yeah. Yes.
Okay. Then you'll find out actually how many places K2 can go to.
Yes.
Then you'll find out how many places K3 can go to.
Yes.
Okay. So
Yeah.
it's not as simple as that. Obviously, like you're missing out on a lot of configuration, right? You just make moving K1 around. Let's say you're moving K1 around. What about arrangement of K2 and K3 when K1 is moving around, right? You're not taking care of that.
Okay.
So
Yeah.
yeah, so you're missing out on some combinations, obviously. Uh,
Okay. Yeah.
Try not to move anything at all. That's my advice for now. Okay.
Okay.
It has something to do with maths. Okay, you count something and then you derive something from there. That's my idea.
Okay. Okay.
Yeah, think in that direction. Take some time. It's fine, and you're doing really good. So chill
Okay.
out. Yeah.
Okay. Um, so right now we have 3 nights.
Mm-hmm.
From K1 we can reach to K2.
Mm-hmm.
At the same time, if we are swapping K2 and K3, we can if we can still reach 1, 2 position from K1. So that'll actually be,
1, 2 as in K2's position, right?
Yeah, K2's position.
Okay.
So
K2 is at 1 1, right? I think.
K2, yeah, sorry, yeah, K2 is at 1 1.
Mm-hmm.
So from 0 3 we can reach 1 1. But
Okay.
then in 1 1 we have two different, we can have two different keys.
Mm-hmm.
Um, we can have two different keys. So that will be the number of configurations we can have at K2
Mm-hmm.
into the times K1 can reach K2. Maybe that could be that.
Okay.
Uh,
Tell me your friend's name. Like, just give me your best friend's name.
uh, Pranaya, Pranaya,
Okay. Imagine that you, me, and Pranaya, okay, are sitting in a room, and let's say you and Pranaya are friends, so you both can exchange. Let's say we all have some ball in our hand, okay.
okay,
Let's say you and Pranaya can exchange the balls that you have, okay.
okay,
And since we just became friends, so I and you can exchange the balls. But
okay,
me and Pranaya directly cannot exchange the balls, okay? So imagine
okay,
that Pranaya has a red ball, you have a green ball, I have a blue ball, okay?
okay.
And we are allowed to exchange as many times as possible between you and me and you and him or her, I don't know. So
Yeah, okay,
now, can you tell me how many different arrangements we can have?
okay. So uh, I can exchange with you. I
Yeah,
can exchange with Pranaya,
yeah,
and since I might be having Pranaya's ball, I can exchange that with you.
yeah,
Since I'll be having yours, I can exchange that with Pranaya.
correct.
So that'll be four, four.
You have three balls. Can I say you can have, like, you have the power of distributing them as, and like, can I say you can have every possible arrangement of balls between all three of us?
Yeah, because I can exchange with you and I can exchange with her.
So can I say that we can definitely exchange balls? Like definitely, like I can have anybody your ball or Pranaya's ball, and you can have my ball and Pranaya's ball, and Pranaya can have my ball or your ball, right?
Yeah,
Can
yeah,
I say we can have all possible sort of arrangements?
yeah, we can say that.
Can we say that? Yes. So now
Yes.
you tell me that how many possible arrangements are there of three balls?
Uh, three balls, and we have to choose between three people. So three factorial, that is nine different.
Six. So
Oh yeah, sorry, sorry. Yeah, yeah, six, six, six.
yeah. So can I say we can have three factorial number of permutations? Yes.
Yes, yes.
Can you try to apply this logic here somehow?
Okay. Okay. For K2 we can reach K1 and K3.
Mm-hmm. So
So that
yourself as K2 and me as K3 and Pranay as K1, right?
one. Yeah.
So we can basically, if let's say we are sitting in a room and we can swap seats, right? So we
Yeah.
can have all possible like combinations of swaps.
Yeah. Yeah.
Yeah. So how many different positions like permutations we can have in this case?
In this case, we have three people, and
Yes.
all of them can swap with each other.
Yes.
So each person is two. So you can have six.
Yes.
That is.
Three factorial. Like there's no brainstorming here because
Yeah. Yeah.
it's the
Yeah.
same question as that only, right? Like where.
Yeah. Yeah.
Yeah, let's come down a little. Let's like change it a little. I'll show you one more thing. So I need to understand if you understand it correctly or not. So can you see the new chessboard that I just pasted?
This one. Dot dot dot.
I'm just writing
K2.
something in there. Can you see that?
Um,
My cursor moving?
yeah, 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 yeah. It's at the top. Yes, I can.
Okay. B, let's see if I have something like this. Or so let's have it this way only. Hmm. So now think of it like this, that from K3 we can reach K4, okay?
Okay.
Now you tell me, just by doing mathematical, like just don't go much into actually doing it. Just tell me how many different possible arrangements we can have.
Okay. So K3 can reach K4, K3 can also reach K2, and K2 can also reach K1. So there are four people can reach all of them. So that'll be 4 factorial. So yeah, that's 6
24.
into 4, 24.
Correct. Now let's say there was one more night. I can't draw it away as a, but imagine there was one more night. Okay,
Okay,
that night was sitting somewhere that K2 and K3 directly can reach it. For example, let's say.
okay, okay, okay.
So now how many arrangements will be there? See, till now we have the linear chain, right? K1
Yeah,
connected to K2, K2 to K3, K3 to K4, right?
yes.
Let's say we have one night, but now K2 and K3 can reach it directly.
Okay. So we should also be adding the number of times they can swap with each other. So that is, if the position was K5
Mm-hmm.
and K2 and K1 can reach K5, so that'll be another 3 factorial. So that would be another 6. So, and 24. So 24 into 6, because for every combination, again, you can have K1, K2, K3, K4 in different configurations.
Mm-hmm. So, no, I'm thinking in a different way, right? Think of it like the same problem, right? Let's say you have K1 as one of your friends, K2 as you, K5 as some other friend, K3 being me, K4 being some other ends, right? Now K1 and K2 can swap seats. K2
Yeah,
and K5 can swap seats.
yes,
K3 and K5 can swap seats. I think K2 and K3 can swap seats. K3 and K4 can swap seats, right? Imagine it like
yes, yes, yes.
so. Do you think that if we have this sort of network wherein two people can swap seats, do you think we can have all possible arrangement of seats, like us sitting on anyone else's seat, by some possible way of
Yeah, 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 yeah. We can have that because even though, let's say K3 cannot directly
reach K1?
access K5, yeah, but we can have a combination where we can do 2 3 swaps, and
Exactly, exactly. So we can basically make anyone sit anywhere,
yeah,
right? So
yes.
now tell me, like, if you have 5 nights in scene and they are somehow connected, how many different possible arrangement of matrix can you make?
So like it'll be total number of nights factorial. So that is
Correct.
if we
That's 5
have,
factorial. Correct.
yeah,
That's the answer, right?
okay,
Now, a final question. Let's say we have these 4 nights which are connected, okay?
okay,
And after that, now let's say at some distance, there are some other nights. For example, let's say we have K5 here, and let's say we have something like this, and let's say K5 and K6 are connected. Okay, I don't know how
okay,
many dots I have to make, but imagine
okay,
that K5 and
okay,
K6 are connected
okay,
now, and they are not connected to the rest of the world. That is K1, K2,
okay,
K3, K4. So
okay.
now you tell me, how many combinations will be there for this board?
Okay. So if only K1, K2, K3, K4 are connected
Mhm.
and they're totally separated from K5 and K6, so
Mhm.
we have 2 different groups.
Correct.
So for each group, we can find its size and do its factorial.
And then what?
And to find the group, we can
And
just
then
union
what?
them.
Sorry. And then
So and then yeah. So it's 4 factorial. So you get the 24, and it's 2 factorial. Like you get 2. So since they're not connected to each other, no matter what, you'll just have to uh, multiply. So 24.
not add.
Sorry. Yeah. Sorry. Add. Yeah. So it's 24.
Are you sure? No, add.
So you have one combination. You can do 1 and 2. It's multiply. I'm really sorry. It's multiply. So 24 into 2.
Mhm.
That's 48. And to find the groups, you can just use a disjoint set to find the group and its size.
So I think you now have some idea, right? Can you summarize
Yes.
the idea? Like, what's the idea? Don't tell me
Yeah.
the code, just idea for now.
Yeah. Yeah. Sure. So I can just traverse through the entire matrix,
Mhm.
and then if I find a k, I'll just put it into one group. In case it doesn't have any group, that will form a group by itself.
Okay.
But then in case it has a group, we'll
Mhm.
just put it into that particular group. So
Okay.
after finding every possible group,
Mhm.
we'll have a certain number of groups. So for those groups, we can again find for each groups its factorial and then multiply it to the answer. So that will be the total number of combinations that you can get.
Yeah, so that's the right idea. I'm like happy with it. Now, Do you think you
Okay.
can code it down?
Yeah.
Okay, so on your right you have this. Which language do you prefer?
C++.
Okay, I do the same. So
Okay.
let's cover line three and let's finish it up. Okay.
Okay.
So you have to return an integer, and you would be given a vector of characters.
Okay.
Okay, so get started.
Sorry. Yeah. So since this is the function that I have to return,
Mm-hmm.
uh, let's just say we have a 2D matrix and each one is a character.
Yeah.
Okay. So, and so, yeah, we can just, we have to traverse entirely.
Mhm.
So I'll be having int row, I'm just pre-computing the rows and the columns.
Okay.
So matrix size and so every for every row,
Mm-hmm.
I'll be traversing through the entire row,
Okay.
and the indentation is an issue.
Yeah, that's there, right? Like that's there intentionally.
Okay. And I'll be traversing through every column.
Okay. Are you pressing spaces or what? Like,
Yeah, I
what do you
can.
think you would want to use tab or something?
Yeah, okay, yeah, I can. I thought.
Shift tab tab shift tab to go back, tab to go right, something like that.
Okay, okay. So I'm over here. Okay. So if it's an night, sorry. So
Give me one sec. I'll just rectify a few things. Okay. Yeah. Continue.
yeah. So if it's a night,
Mm-hmm.
I'll be K.
Okay.
I'll be just putting it. Yeah. Uh,
I like to see you struggle.
yeah. So I can just put it into the group. So that's basically I'm going to union it.
Mm-hmm.
Uh, so I can. So how do I union it? Um so I can find. So let's say I'm at position K1.
Mm-hmm.
So I can go to all 8 positions from that,
Okay.
and I'll have to union it with all those 8 positions.
Okay.
Uh, so if I'm at position 0, 0, 1, 2, 3, yeah. So K1 is at 0, 3. So I can be going into 8 different positions from K1. So unless I'm not going out of boundary, and if I'm within the boundary and I reach a K, I'll be grouping them both.
Okay.
So I'm at 0, 3. I can be reaching 2 on top, 1 to the right. So it'll be -2, comma 2. If from 0, 3, it'll be -2, comma 2. It'll be another one would be -2, comma 5. Another one would be
Okay.
0.
Anyways, we got those. Let's say what next?
Okay, so we got those. I can union that position with the present position. So what I'll do is I can find the parent for this one. So let's say I'm having an uh, I'm having a function which will get me the pair for will get me the parent for K1.
Okay.
So I'll be passing R and C,
Okay.
and I'll be getting the parent for the present one.
Cool. Makes sense.
Okay. And I can also get the parent for the all 8 positions. Let's say parent P is equal to find pair of, we have those positions already, so that will be x comma y. I'm assuming those positions to be x comma y.
Okay.
So I'll get them. In
Okay.
case the parent don't match,
Mm-hmm.
if parent K is not equal to parent P, I can just union them.
Correct.
So I can union them. So union of these. So R, C, X, and Y.
Don't you think you'd just want to pass like pair K, pair P because you've already calculated
Oh,
pair?
yeah. Will be pair K and pair P.
Okay.
So we'll find, so this will be the union of everything.
Okay.
And now we can just traverse through the entire array of the parents.
Mm-hmm.
So I can maybe have a map where for each parent I'm storing its count. So suppose I have, let's say I have a group 0,
Mm-hmm.
and 0 has 4 nodes. So that'll be for group 0, I'll have a count of 4, right? So I'll find the entire count using a map data structure. And after that, for every value of the key in the map, I
Yeah.
can just find its factorial and multiply it with the answer. So after
Cool.
finding the
We're
answer,
aligned with the thoughts here, which is good. But now I wanted to complete the code. Like this is like in bits and pieces, right? And
yeah,
most of
yeah,
it
yeah,
is in your head. So
yeah.
uh,
Union was a keyword, so I just changed it.
that's fine. Now I think that this piece of code, like line 10 to 12, should be inside some sort of for loop where
Yeah, yeah, yeah.
you're finding x and y, right? For all eight
Yes.
positions. So how do you do that?
Okay. So in the beginning, every position will be the parent of itself, and then we can just find the parent. So
Okay,
if we
let's forget the find parent thing. Let's forget the union thing. Okay, I'll make
okay,
you write those later.
okay,
For now, calculate all eight possible x and y.
okay. Uh, so okay. So if we are given, if we found a k in position R and C,
Okay.
we'll have 8 different configurations, right? So
Yeah.
one of the for configuration would be to go two above and one on the left. So that will be nothing but R minus 1 comma C. Sorry, that will be nothing but R minus 2 comma C minus 1. That'll be one of the configurations.
Mm-hmm.
So can I just add the configurations over here?
Do whatever you want to do. This is yours.
Okay. So one would be two above and one on the right, so minus 2. So R minus 2 comma C minus 1.
Okay, you can skip the R and C, right? Like I think you just
Okay, yeah. One will be minus 2 and minus 1.
okay,
Another would be minus 2 and plus 1.
okay,
Another would be minus 1, that is, we're going 2 to the left and 1 on top.
okay. You
So,
don't have to explain. Like just like write it down.
yeah, okay.
This is
So,
correct, though. I'm like just
okay,
trying to save your time.
okay, sure. So, that'll be minus 1, comma, minus 2.
Mm-hmm.
Another one would be minus 1, comma, uh, plus 1. Oh, sorry, can I just see if
No,
this
plus
one works?
doesn't work, right? So
Yeah, so 2, that'll be 0, 1.
see, I would suggest this one thing, right? Like fix the left side and for right side just do combination, like you did for minus two, right?
Yeah,
Minus one, minus two, plus one. Similarly, minus one, fix minus one. Say minus one and plus two, minus two
yeah,
and plus two. Similarly, fix other one.
okay,
Yeah,
okay.
that'll be easy, right?
Yeah, that'll be easy. So now I'm going to the right, so that'll be
fix plus 2 and then do -1 minus plus 1, something like
Yeah, okay, fine. So
now
another
fix one.
2, 2, 1, 1. So 1 and minus 2 and 1 and 2.
Correct. Awesome.
Yeah. So these are the 8 positions. So for every position, we can find its parent, and we can check for the union in case the parents were not equal.
Again, let's not focus on the parent. I want to do like write some code here so that this piece of code from line 9, 10 to 12
Okay.
uh, has x and y, valid x and y. X is basically r minus plus something, and y is c minus plus something, right? I want to see you convert this all into actual code wherein
Okay.
x and y
So
will contain those values. Yes.
okay, fine. So I can so for every minus 2, I have a minus 1 and plus 1, and so yeah, for every 2, I have a 1, and for every 1, I have a 2. So I can put them into two different vectors, or one for the rows position and one for the columns position.
Do that.
Yeah. Okay. So let's say these were the rows positions. So one of the rows positions could be minus 2,
Mhm.
one could be minus 1.
Just copy the first values of all the pairs that you created, right?
Yeah. That's what. So minus 2, minus 1, 2,
Just
and 1.
directly copy them, like blindly, like copy the first 8 values. No.
Oh,
I mean, like copy as in like write. You have to write it down. For all of the 8 pairs, just copy the first values and put it here. So it should be -2, -2, -1, -1, 2, 2, 1, 1.
okay. So minus 2, minus 2, minus 1, minus 1, 2, 2, and 1, 1. Yeah.
Correct. And name this something else because we have
Yeah.
reusable row.
So
Uh,
since this will be a small difference, I'm just going to name it as dr because my row is
which
r.
cool. So make it a vector, right? Like don't put it in comments now. Like we're actually writing down
Okay.
code here. So
Okay. Yeah, sure. Okay. So
sorry, that's not how we do it. You have to say equal to. Uh,
yeah.
okay. Similarly, write for dy as well, dc as well. Sorry.
So it's minus 1, 1, minus 2, 2, minus 1, 1, and minus 2, 2.
Correct.
Okay. So if we found a k, we can just run a for loop for the 8 times to get the 8
Okay.
configurations.
Do it at line 13 again. I mean,
Yeah.
because we want
Yeah. We
to do it
don't need to,
with
yeah, call it again and again.
yeah.
Okay. All int position equals position less than
8.
8 and position plus plus. Okay. So we can find a new parent. So
X and Y. You have to calculate X and Y.
yeah, the parent positions. So int x is nothing but r plus dr of position,
Okay.
and int y is nothing but c plus dc of that position.
Okay. Now another question. Why are we having plus? Why are we not having minus?
That is because I've given it a negative over here, so
So you're
it'll.
preferring plus and not minus?
Sorry, I couldn't get you.
I'm trying to confuse you. That's
Oh, okay. I've already given a negative, so even if I add it, it'll go to the previous position.
good job. Yeah.
Okay. So now what I can do is I can check if they are valid.
Mm-hmm.
If let's say I have a function for valid x, y, and I'm also passing my matrix to get the sizes. In case if it was not valid, I'm just going to continue. So I can just do that.
Okay.
So continue. Else I can be doing this part.
Yeah, so just copy it down, copy it above. Sorry.
Yeah. Yeah.
Okay,
So
now please write the code for valid.
okay. Uh, so I can just write it over here.
Mm-hmm.
Full valid. I have int x, int y, and vector, 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 mat.
Because at one place you're calling it matrix, at one place you're calling it mat. Why?
Uh,
Now you've got
that,
comfortable. Is that
no. Anyways, I'm passing it by reference. So whatever name I call it, it wouldn't matter.
that is absolutely correct. Now, but why? If they're representing the same thing, why are you changing names?
Actually, I didn't notice. I just wrote it as mat. That's it.
Okay, that's actually not right to do so in actual production code. But okay,
Okay.
I get
Okay.
your point. Now, since we are at reference and all, right? Like, I would like to
Yeah.
ask you a question. So, what is this
Okay.
and thing that you've written?
So whenever it's the AND, I'm directly giving the address of the matrix. So over here, let's say if it was at 100, I'm giving the address. But then if you're not,
Why do we care?
that is because if you don't pass it by reference, you'll be creating another instance of the entire matrix. So if you keep calling the function over and over again,
Mhm.
the memory like at the heap would be exhausted at some point.
Uh,
Given,
I don't
gi-
think so. So, uh, I'll tell you. So, let's say when you call a function, right, and you pass a copy, but
okay,
then when the function returns, can I say whatever your function allocated?
yeah, it gets destroyed. Yeah.
Yeah. So, why are you saying that it's gonna pile up? It's eventually getting destroyed, right?
Yeah. Actually, yeah.
What's the reason? Why are we using references?
That is because if I make a change in my matrix right now,
Okay.
that change will prevail because I am
But we don't
actually
need to
doing.
make a change here. So that's
I don't
also.
need. Yeah, I don't need to make a change over here. So
So
it's
why
fine
are
if I. It's
no?
fine if I don't pass it by reference.
Okay, here you're wrong now.
Uh, okay. Actually, I'm not changing any value in the matrix according to the function
That's
bool val.
absolutely correct. But why are we passing it as a reference? I'm pretty sure you have done a lot of lead codes you must have seen, or like you must have wherever from you've learned, right? You
Yeah.
learned that okay, pass it by reference. But why? That's the question. It's not taking a lot of extra memory that your heap is gonna,
Yeah.
exhaust out and all.
Yeah. That's there.
You allocate and then you deallocate. So one allocation is not gonna like trouble you much. But now the question is why? Even if you're not changing anything, right? So we don't need reference here. But if you say we don't need it, I'm gonna say no because we need it. So why?
I actually am not going to change anything in the matrix.
Yeah. So why are we passing reference? That's my question, right?
I generally pass it by reference so that I don't really need to uh, have many duplicates of the same thing. Or else, if I want to really change something in the matrix and I want to have those change values after I call the function.
Okay, let me help you here. Okay. So
Okay.
I'll tell you why we pass by reference. We pass by reference for a few things. One is obviously we don't want to create memory. As in, like when you create a copy, it definitely takes some memory, right? Although it
Yeah.
gets reallocated, but we are at some point in time we're taking some more memory, right?
Yes.
It can
Yes.
be avoided. Second is obviously you also mentioned that okay, when you pass by reference, whatever changes we make, it gets reflected to the original place wherein we declared it, right? Third thing is we pass by reference and not by copies because, for example, let's say you're passing a matrix, okay, which has let's say a million elements.
Okay.
When you pass by copy, obviously you're creating a copy, so that would take a million operations
Yeah. Yeah.
to copy the elements. That's gonna take significant amount of time if you're calling that function again and again, right?
Yeah.
And obviously, every time we are calling valid, it would create a copy of the whole matrix, which is gonna take like two for loops over the matrix, right? Imagine it like that.
Yeah. Okay. Yeah.
So that takes time to create copy.
Okay. Okay, if the matrix was really huge, yeah, it would take a lot of time to create.
Yes. Now, second question. So, what is actually a reference? Like internally, can you tell me like what is reference?
Okay, so a reference is nothing but like suppose I have my value in an address say 100.
Mm-hmm.
So when I'm passing it by value, I'm just going to give the value to the function.
Correct.
But then when I pass it by reference, I'm actually giving it the address of the value. So if my value is at the address 100, I'm just going to give it the address.
So, how much
So
memory does this reference take then?
it would just take the number of bytes. The suppose for integer it would take 2 bytes, right, in the memory. So
So, for this vector, right? Like this thing.
yeah,
Yeah, its reference would take how much memory?
um, it's a 2D matrix.
Yeah.
Each is a character. Character is of one.
Uh-huh.
Uh,
Character is a 1 byte
yeah.
in C++.
Yes.
Okay.
Uh,
That's news to me.
uh, it's one.
I'm just kidding. Oh,
Okay. 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 And then we need to store the entire thing. So it's basically we can have it either row wise or column wise. So let's say I'm having it by row wise.
okay, let's cut it. So, see, if you pass a vector, a matrix, or maybe a 2D vector, an array, or a set, or a hash set, or whatever, right? Like you may have like
Yeah.
a very fat class, an object, whatever. If you pass its reference, a reference is basically an address is basically an integer.
Integer. Okay.
Yeah. So no matter what container it is, if you're passing their reference, you're basically passing their base address, which is an integer. The
Okay.
reference internally is an integer only, unsigned integer.
Okay.
It is gonna take 4 bytes only.
Okay. Okay.
So let's continue.
Yeah.
Good discussion.
Okay. So I'll have to be checking first if it's going out of bound.
Okay.
So so yeah. So I'll just be writing if x is less than 0 or x is greater than or equal to matrix dot size.
You already calculated that, right? Like row and column. Could you
Yeah, yeah,
almost
I could actually pass that. So that will be nothing but row comma column. So over here it will be in row comma int column. So
don't why did you remove that matrix thing actually?
yeah, I should be having that to check for the k value.
Yep. You can copy the reference thing from down here.
Yeah. Okay. Or uh, if y was less than 0 or y greater than or equal to column, or if the matrix of x and y is equal to empty cell,
Okay.
we can just return a false,
Okay.
else we'll just return a true.
Okay.
So
Next.
this will check for the out of bound and will come here. So after coming, in case if it was valid, we'll come here and we'll find the parent.
Okay. My question is, let's say, can we put this matrix of x y equal to dot before at this place?
Um, no, that is because if x or y goes out of bound,
Okay.
it cannot really get hold of that value.
What will happen to our program?
Uh, it'll throw an error saying
What error?
uh, that I don't remember the exact name of.
Segmentation fault?
Yeah, yeah, yeah. You can say segmented fault because you will not be reaching that point because whenever you are calculating a particular address, the indices should be positive.
Mm-hmm.
So because we are passing also by reference,
Mm-hmm.
we can find the address by the x's and y's,
All right.
and then we'll get the particular address. So that's the reason we'll be checking. In case if x was lesser than 0, it will
Mhm.
not be calculating for any of the condition over here.
Makes sense. Okay. Cool. Let's move
So
forward, right? So this bool is valid is okay.
yeah,
Let's come down. So what you have done is you have calculated parent find pair of x comma y. Then if they're not equal, you've done the union, okay?
yeah,
And yeah, let's say after this you can write down the code for that. That's fine with me.
okay,
Now, what you would want to help me with is figure out how to write down this union code and stuff, finding parent.
okay.
Although we are officially, I think,
Out of time.
are we? No, we still have 2 minutes, right? Yeah.
Yeah,
So let's do it.
okay. So generally, if it was a 1D matrix, we could have just calculated with x alone.
Mm-hmm.
Uh, but then it's x and y this time.
Have you ever
So
done this?
uh, yeah, maybe every x and y can also have a unique value.
Correct.
So let's say I have a number of columns. So over here, maybe if it was 4,
Mm-hmm.
so I can just do x into columns plus y. So that will give me a unique value.
Correct.
So initially for the entire row plus column,
Mm-hmm.
I can assign everything to its own. So whatever value I'm getting for x into column plus y, I can put it for the xy. So I'll be having unique values.
Awesome. Can you write down the code like thoda sa?
Yeah, yeah, sure, sure.
Okay.
Uh, so okay, so instead of finding xy, I can just say int index is equal to x into column plus y. So I'll be just finding the parent for this index,
Okay.
and yeah, and I can also be finding the parent for this.
Correct. I'll do that. You please write down the code for this. Just leave it. Write down the code for that find parent and union.
Yeah, yeah, sure. So int find pair of int node comma. I have a vector int. I didn't initialize this parent yet. So if my node was equal to the parent, that is, if the node was the parent of itself, I
Mm-hmm.
can just return this node.
Mm-hmm.
Else, I can just be finding recursively the parent. So it will be parent of node, comma parent.
Okay.
So this will give me the parent
Correct.
of both x of the position xy and of the position this
Got it.
thing, and I can do the union.
Yeah. Now tell me
Uh,
the union code, please.
yeah. So it'll just be void union of let's say int node x the int node y,
Mhm.
and we also need the vector int parent.
Okay.
Okay. So I can assign anyone. So I can either assign parent of node y to be node x, or I
Okay.
can assign a parent of node x to be
Got
node
it.
y.
Let's do that.
Yeah. So parent of node y is equal to node x.
Okay.
This will be assigned. We'll be finding the parent. We'll be finding the union, and we can do that. So we'll get the parents. So now after we
Where is
encounter
this parent vector? I can't see it anywhere.
yeah, sorry, I'll just be doing that.
Okay.
So vector int parent of I'll be having a total of row into column
Mm-hmm. Are you
this
sure?
thing. Yeah, because if I have 2 cross 2 matrix,
Hmm.
so each cell is a parent of itself. So that is nothing but there are 4 cells. That is 2 into 2. So I'll be at present none of them will be uh, in none of them are in a group, so they'll be a parent of themselves, right? So it'll be row into column, so those may number of cells.
Correct.
So into column, and I have to initialize it.
Mm-hmm.
for every row and column. So maybe instead of initializing it, we can just do it over here.
No, you cannot.
Uh,
Because here you're using it, right? Maybe you might use something which you don't have access to.
yeah, the previous ones. Yeah,
Yeah.
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 So I'll have to be assigning them.
You just
So
write for loop, something like that. Yeah.
yeah, yeah. Should I be writing that down?
Definitely, definitely. Just
Okay,
copy this code, man. Like just copy this and
okay,
paste it, and then see. This is what you would want to do in an interview, right? Like
okay. Yeah,
paste, save your time. Interview is gonna probe you to different questions, right? Which might interest them, or like I'll talk about it. Don't worry.
okay.
Yeah.
So this is nothing but parent of uh, R into column
Mm-hmm.
plus C
Mm-hmm.
would be nothing but itself. So R into column plus C. Everything is a parent of itself. So for a particular cell, I'm finding. So if it was 0 and 0, it'll be in the parent 0, and its parent is itself, so it'll be basically 0. For 0, 1, it'll be 1.
Could I have written something like this in this asking instead of what you've written?
Uh, yeah, because we are having all the values 0, 1, 2, 3, 4.
Mm-hmm.
We can put them in. Yes, yes.
Okay, which is a better way and why?
Um,
Essentially, if I burn it down to operations level, right? Like, what do you think is a better way?
okay. For the code that I have written in,
Mm-hmm.
every time for every hour, I'll be checking for every. So basically, I'm assigning some value to C. So so that would take, you know,
Okay,
it
so
actually takes the same number of operations as.
correct. So on a high level, yes. On a low level, no. So what my code is doing is two things. One
Okay.
is
I,
multiplying every time, right? Which
yeah,
is a multiplication operation, which is a little heavier than plus and all.
yeah.
But you can see your code at every operation, it is doing two multiplications.
Yes, yes, yes.
So which is bad, honestly. Like,
Mine, because
yeah.
it's doing
And
two.
actually, I can avoid mine, but you can't avoid yours. Like, I could have just
Yeah, yeah. You
like
could have found it before.
yeah, you also could have done it here, but like it will still take some operations, right, for you to
Yes,
multiply.
yes, yes,
Because we
yes.
have two loops, so why to complicate it?
Yeah.
Anyways, I get your idea. So yeah, this works. Hello, now one final question before we close it all down, right?
Okay.
So I'd see your union and find parent code is like very plain vanilla, right?
Yeah, yeah, yeah.
Are you aware of any techniques which can like help do?
Yeah, yeah. What happens is, over here I'm just assigning the node
Hmm.
to as a parent of another node.
Yep.
But then let's say we have a group of two and we have a group of five. So it's easier to traverse a group of two than a group of five. So if we attach a group of two to a group of five, we
Mhm.
have to be going those many number of steps ahead. So instead, whosever rank is more, uh, if you're going to uh, if you're going to assign that one's parent as the child,
Okay.
that would reduce. And also another thing is, let's say two is the parent of one,
Mm-hmm.
and three is the parent of two. So
Okay.
3, 2, 1.
Got it.
So whenever you're finding one's parent, at the end you will always boil it down to three.
Okay.
So instead of just recursively running, we can maybe change the value of the parent of the node, right? So it'll be nothing but parent of the node is equal to whatever we find, since
Awesome.
this will be
What is
returning
this technique called as?
um,
There is a name.
rank compression, rank by compression.
Oh, so this rank and all is union by rank. Okay, that
Yeah.
technique is told to find union. While doing union, you can compare the size of the unions and then make a decision, right? That's
Yes.
what you said there. Now, that's union by rank.
Okay.
Now, what is this thing that you just said, like wrote it down, right? Like that. Okay, after calculating, you're going to return that. So use that as a new parent.
Yeah.
Yeah. So what's this thing called as?
Uh,
Path compression.
okay. Yeah.
You're
Yeah.
trying to compress the path. Okay.
Path. Okay.
ठीक है. Yeah, this all looks good to me. Now I think we can officially close the interview, right? So it went till 12. Now you can calculate the
That's-
time. So
Yeah, I still have a thing pending because I'm not really returning the total number of configurations, I
I
guess.
know that. I know that. I know like this is all write down some code after this, after these two for loops at the end, and then
Yeah,
like find out the size of components, and then find their factorial, then multiply them, then return them. So see, I understand. If you can write down this code, then you definitely can write down that as well.
okay.
Now it's time for face off. So congrats on completing your first interview, right? This is
Thank
your first
you.
interview, right? That's what you said.
Yeah, this is my first mock. I've just given two interviews for my intern ones. That's it.
Okay. So, like, what's your experience for
Uh,
this interview? Like, you can just be plain raw.
yeah, yeah, sure. And actually, I was literally very scared because I joined by 11:58 and you weren't there that time. So
Uh-huh.
I was like really nervous since then.
Okay.
Initially, also, I was nervous. Maybe that's the reason I've been making a lot of mistakes.
Mm-hmm.
Uh, After that, I was fine. Like, I was fine with you interviewing me. Like, it was chill after a while, maybe let's
I,
say
I
sometime.
try to keep it chill, right? Like,
Yeah,
see, I mean, like, I was interviewing, like, since you told me, right, that you were interviewing for the first time, having some mock for the first time or something. So I could relate it to my experience, right? Wherein when I was in college, like, I was sitting outside and in my placement cell, like, some interview and all is going on, and I'm constantly thinking, it's my turn next, it's my turn.
yeah,
Like, you have that, I don't know what you have, right? So I could understand. That's like trying to keep it very chill and plain. So, but at the same time, obviously, I have to interview as well. So I got
yeah.
to do what I got to do. So but now coming to it, right? Honestly, you did a good job
Okay.
at explaining things, whatever you understood. Second thing that I liked about you is you have understanding of things, as in actually understand a lot of things like which people don't. And I mean, at first I thought that you're speaking, right, or you don't understand, but then you actually presented those things to me, right? Like for example, I could see you have done a lot of work, right? Like all of the things that I could see in this code, you don't get it in one question, right? You get all of these ideas in different questions. So looks to me that you have actually solved a lot of questions, right? And I'm
Yeah,
very, very happy that with some help you were able to put it all together, right? For
yeah,
example, this direction thing. I mean, although I posed you a little here, but like
yeah.
you got it on your own. You maybe remembered it from somewhere or something, right? Other than that, this thing of converting these coordinates, pair of coordinates into one number and then using that, right? Other
Yes.
than that, I could see you're using this union find and all very beautifully. People actually would go for DFS here, but you used union finding and all, which I'm very impressed with. Other than that, I was a little afraid that maybe you would not be able to get these X and Y's, right? You've written X and Y, and then I was forcing you, and you're trying to probe around, right? So
Yeah, yeah.
I was seeing that maybe you're running away from this piece of code of generating these X and Y, but you
Okay.
finally delivered it, which I'm very happy with.
Thank
Uh,
you.
Other than that, this reference discussion was cool. I mean, you had some understanding, which is great. Not all, but that's
Yeah,
expected, honestly, from a fresher. And other than that, yeah, I mean, like you were able to put it all together, like this union and find parent thing, and you could understand, like you do union by rank and find parent, and then they do this path compression and all, which again I'm very impressed with. And then in this valid thing, you said that okay, we cannot have that before this, right? You had
yeah, yeah.
for that as well. And yeah, so from code point of view, you are spot on. From
Okay.
speaking and explaining point of view, what you understand, you're spot on. From knowledge point of view, you're good. Now, let me come to the part which might be a little disturbing, right?
Yeah,
You explain a lot, right? But I think you get lost there. As in,
yeah,
you stop and you start explaining. You start enjoying it, I think, right? And then you don't talk. You don't write down the code.
yeah. Actually, I kind of like teaching, so maybe that's
I
where.
get it. I'm a teacher myself. I teach a Scalar Academy.
Oh, okay,
Yeah.
nice.
So I understand. Like, where do you teach and all?
No, no, no. Just like I have a brother who's pretty much younger to me, so I teach him math at times, and then I teach my friends in school, college, and everything.
Awesome, awesome,
Not anywhere else.
awesome. So see, the thing is that you would want to maybe like you speak a lot, and which is good. But while speaking, try to write down the same thing. For
Okay.
example, let's say you're writing down this union code, right? So what you would want to do is maybe you would want to say that, okay, I'm going to now create a union function, okay, and now inside it, what I would want is I would want a node. Maybe I'll keep one index, right, and I'll keep index of the other guy that I want to join it with, and also I need a parent vector, right, something like this.
Okay.
So I'll keep that. Over and forwards. Yeah. So after that, I'll say that, okay, now I'll make a decision on which one should become the parent of other one, right? So
Yeah.
I'll maybe say for now that, okay, parent of node Y should become node X. We could have done the other way around as well, but that's fine. If you want to, like, so see, I spoke, but at the same time I wrote down the code, right?
Yeah.
It's gonna save you time.
Okay.
You would want to save time for yourself because you don't know what's upcoming next. Maybe the interviewer came with two questions.
Okay.
You've
Yeah.
only done with one, so that's gonna leave a very bad impact. He's gonna write that in feedback that, okay, the candidate was only able to do one question.
Okay.
So speak a lot, that's fine, but with that, like, you need to write down the code. Don't stop at any point. Okay,
Okay. Sure. Sure.
just burn down the problem. Other than that, from the idea point of view, right? Honestly, you didn't solve the problem.
Yeah, I didn't.
You took hints. You took a lot of hints, which I'm obviously gonna mention if I was actually interviewing you. But I think still, I mean, I'll give you the benefit here, right? Like, you still did a pretty good job and like taking that forward and all. So honestly, from the idea point of view, I was a little less disappointed. But then you covered that disappointment by like while writing down code and the further discussion that we had. So I'm quite impressed there. So
Okay.
I mean, I have mixed feeling of this. I might give it a lean higher, like not a full hire, but I might give it like a lean hire, as in, okay, I'm like, okay, sure of hiring her. Like,
Um,
that's that maybe translates to 7 out of 10. So
okay.
yeah, the only missing part here was actually the idea. Okay, that
Okay.
you were like, even after I gave you some hints and all, you were like, let's just 2 into 3, 5 into 6, something like that. You had the factorial thing is what I was missing. But once you got that, then you said that, okay, we can multiply and do stuff. So which I'm happy with. Uh, Okay, so from knowledge point of view, I think you're good. Like, from coding point of view, you're good. From communication point of view, you're good. So these three things are good. The things that you need to improve on is a few things. One is obviously, like, solve more problems so that you can
Yeah.
get more ideas and all, right. Try to actually get good ideas rather than speak beforehand, because see, once you give a wrong idea, right? Everything, if you whatever you say in an interview basically gets recorded,
Okay.
as in somebody's going to take a note of it that, okay, the candidate is said this thing which is wrong at this point.
Okay.
We would want to minimize those things.
Okay.
So for that, like, maybe best thing that I do in interviews, let's say somebody presents a question to me, I would talk first and this understand the question well. Once I understand, I'll run it through some examples, and then I'll take a few minutes. I'll tell the interviewer that, okay, give me 2 3 minutes, I'll think over it.
Okay.
Once I have some more further maybe openings and all, I'll discuss that. Rather than discussing something wrong, I would do that.
Okay. Okay.
Okay, don't present wrong ideas. Maybe, like, if you're unsure, okay, if you have nothing, maybe you would want to present them. But if you think you can still make some progress, do it. Also ask for hints. If you think it's really long time, it's getting awkward, right? Silence and all. You can ask for, maybe can you give me some direction? Maybe I can chase that direction, right? It's better than nothing. See, let's say if you are not able to solve this within, let's say, 7 10 minutes, right? 5 7 minutes, whatever you feel that you're not getting any ideas, you can directly ask me that, okay, can you give me a hint or something? So although that might be a negative point initially, right? But you can see that once you have the idea while writing on the code, you can cover up for it.
Okay.
That's
Yeah.
better than you not getting anything and you not writing on the code.
Okay.
Did you
Yeah.
get my point?
Yes. Yes. Yes.
Okay, awesome. Other than that, on code, right? So I can see there's problem with code writing style.
Okay.
I'll tell you what the problem is. So your code is good. Like, even like nobody would find actual like big problems, but the small problems that bother me are like, for example, there is inconsistency. As in,
Okay.
sometimes you would put a space after the and. Sometimes you'll put a space before the and. Sometimes you won't put a space at all. Like, if you
Where
see
is that?
find, pair, union, and valid, right? In all of these three functions, if you
Yeah.
see the reference that you passed, right?
Okay. Yeah.
Sometimes the space is before, sometimes the space is after, sometimes the space is like not there.
Okay.
Okay. Other than that, at some point, let's say you're writing down if, right? So after if, you're writing down the thing in like just after that, not writing down in brackets. Okay.
Okay.
Like for example, like here you can see you've written down continue. After here, you've written down union here. Can you see line 39
Yeah.
point?
Yeah. 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 I
You,
can.
you can see that, okay, you've written it down downwards, right? Now, why not in right side then? Why are you not
Okay.
consistent with the code writing style, right? I would
Okay.
suggest forget all of this. Don't put it like this. Always take a bracket and put everything inside.
Okay.
See, I'm talking
Okay.
from a production point of view, right? Like wherein people would actually look at these aspects. Uh, Other than that, yeah, maybe you want to introduce some spaces, right? Like they say after comma, like you have put some spaces here, right?
Yes.
In these vectors that you've created. So
Yeah.
why don't you do the same for these? Like for example, you multiplied, right, row into column plus C, right?
Yeah.
Maybe that makes it more readable.
Okay.
So we have points for everything, right? That is their code readable and all or not. So your code is actually good. Like it's like 8.5 out of 10, I would say. The only
Okay.
missing parts are these only consistent in consistency and all. Other than that, for some functions, like for example, see this find pair is having camel case. Union is not having camel case.
Yeah.
Its first word is capital. Then valid is having camel case because there's only one word. Total config is having camel case. So why not union then?
Okay.
Yeah. So these kind of things like just keep an eye on. Other than that, like I'm happy. I'll give this interview like 7 out of 10. Uh,
Okay.
the missing two would be from two to
Oh.
0.5 would be from the idea actually. And other than that, I'm honestly happy. Like I
Okay.
didn't think that you would be able to code this whole thing down, but you did. So uh,
Okay.
it's just that we need to like put us a time where we need to look at it. Other than that, it's all fine.
Okay.
So yeah, that's my feedback, Priya. Anything you want to ask?
Um, no, I just wanted to know, like, I wanted to basically take a mock to see how I perform.
I get it.